Last time around we ended here, streaming to disk by appending to the end of the file and writing continuously in a loop. And we threw together these error clusters as well. But we really didn't talk about what they mean, so let's do that. To begin the discussion, I'm going to simplify things by removing the while loop, the timing, and all that other stuff used to stream to disk, and keep it simple. And we'll first remove the error cluster. Bring these in a bit, and write to text file as before. Now we already saw that I can write something like text to the file, run it, pull it open, and there it is. Runs very smoothly. But let's gum it up a bit and create an error. How can I do that? Well, with my context help, I can see that one of the inputs to the set file position is the offset in bytes. Now if I leave the from input as default, which means from the start, and then go to offset in bytes and put in a -2 bytes, what does that mean? That means I'll start writing to the file before the beginning of the file, which doesn't really make sense. So that should generate an error. So let's try it. I run it. And indeed, LabVIEW flashes on this function and pops up an error dialog box. Error 4 occurred at set file position in fileio.vi. Possible reason is the end of file is encountered. Well, we know actually that it was the beginning of the file. So close enough. So continue or stop. I'll stop. So let's take a closer look at what just happened. In fact, I'll put this in highlight execution and run it step by step. Our first function executes. No problem. Our next function executes. But before our next function does, we get the error here. In other words, LabVIEW stops this VI and says, wait a minute, you can't go any further. This function has an error, and it gives me the error. Now do I continue or stop? What we see here is called automatic error handling. That means LabVIEW will stop the VI whenever an error occurs, right in its tracks without going further. Now in some cases that's okay. When we're developing and we're testing and we have an error, then we may want LabVIEW to stop and then tell us what the error is, because we as the developer can fix it. However, in a completed application that's running in production, we never want LabVIEW to just stop on an error. That could be dangerous. Imagine that we're using LabVIEW to fly a plane and an error occurs and LabVIEW just halts. Dangerous. Or we're doing some combustion tests and to initialize we open up a bunch of burners and flames are flying and an error occurs before we shut down. Well, that's dangerous. So good examples of where we don't want LabVIEW to just halt whenever an error occurs, but we want something to happen. We want LabVIEW to see that an error occurred and then allow us to do something as a result. That's the whole idea behind error handling. Proactively determining what types of errors can occur and then planning out a resolution for those. The first step is to move from automatic error handling to what we call manual error handling. In some cases, we may want to go to File, VI Properties, Execution, and then uncheck Enable Automatic Error Handling. But in most cases, the best way to employ manual error handling is to use the error cluster. Let's do that. At the bottom left and right inputs of most functions and VIs are these error in and error out. Let's connect them up. And now we're still going to have an error occur, but let's watch what happens. The first function runs, and it says, OK, no error occurred. The next function runs, but it outputs along the error cluster the error. Let's watch this next function. It actually executes. And finally, at the end, LabVIEW flashes over here and says, here's the error. Error 4 occurred at set file position in fileio.vi. This is the same error, but we receive the notification at the end of runtime instead of where the error occurred. But before we see why that's so good, let's take a look at what's in the error cluster. In fact, I'll just go ahead and create an indicator right here. And on the front panel, I get out the error cluster. There are 3 elements in an error cluster: the status boolean, which indicates whether yes or no an error occurred; the I32 code, which tells us what the error is by its code; and then the source, which is a string, which tells us where the error occurred. So if I run this, then we get that error saying yes, an error occurred, it's error 4, and it happened at the set file position function in the file IO_vi. Well, this VI is the file IO_vi, and this is the set file position. Now notice what happened when the error occurred. Again, reemphasize that LabVIEW does not stop here, but instead passes the error along to all subsequent functions and VIs. Now those functions and VIs do execute, but they don't execute their default action. In other words, I'm not actually writing to file. If I see that an error has previously occurred, I probably don't want to write to the file. But what it does is it just says, oops, I see an incoming error, I'm just going to pass the error along. And so it executes, but only just to pass the error. It does not execute its default action. That's true with most native LabVIEW functions and VIs. They don't execute their default action in the case of an error. But there are some cases where we'll want to execute code regardless of an error, and even some cases where we want to execute only in the case of an error. Those VIs that we make to do that are typically called error handlers. So if we go back to the combustion test example we gave earlier, we would want our application to see that an error occurred and then shut down safely. So go down the normal shutdown procedure to turn off the burners and be safe if an error occurs. Or, in the case of flying the plane, if an error occurs, we may want an error handler to come in and see what the error is and try and fix it so that we don't crash. But again, the default action for most VIs and functions is to not execute their normal action in the case of an incoming error. So now we have a good understanding of what general error handling is, the difference between automatic and manual error handling, what's in the error cluster, and what error handlers do, as well as the default action of most native LabVIEW functions and VIs when they see an incoming error. In our next episode, we'll understand how to architect our applications to respond effectively to errors by using that error cluster. And as always, we deliver this type of training live, in the classroom, or online. Just check it out at 6clear.com/LabViewTraining.